Why are chemical reactions important? You can put it in the chat because I switched it so you can just tell everyone, or you can just come off mute and tell us. Good, Omar. So Omar said they cause changes, which is exactly true. And Will said that we're able to understand and explain how the natural world works. Your life as you know it would not exist without chemical reactions, right? Good. Mila helps us understand the properties of matters. So literally like your life, like how we're sitting on the computer right now and working, because some of you don't have your computer plugged into the wall and you're working on a battery. That battery is chemistry. Your internet, like all of that is chemistry. Your cell phone is chemistry, right? So like the whole world is chemistry. That's why I love chemistry so much, because everything is chemistry. There's no way like around that. Chemistry is a big part, like the battery in your cell phone. I don't know if you noticed, but when iPhone put out their new phone, they talked about the battery life being better, right? Yes, Stradeja, she says science is everything, and it is, but like just everything with chemistry, like the chemistry that goes into your cell phone battery is really amazing, and it's something that we talk about in AP chemistry, like how to make a better battery. Because I don't know if you guys noticed, like after a certain period of time, have you noticed like your phone starts to like lose its charge? It doesn't hold the charge as well, and that's because the chemicals in there are starting to lose its reactivity. And so literally like your battery's sort of dying, and there becomes a point where you can't recharge it, which is when you sort of need that new battery. I don't know too, I've seen it in my phone. Have you guys ever seen where like the battery sort of blows up in the middle? Like it's like a little rounded. I've had that before. And that means that those chemicals are reacting and creating a reaction that we don't want, that can be actually really dangerous. But there's a lot of chemistry that goes into all of that. Okay, so let me finish putting on my attendance real quick. Making sure no one snuck in here. There we go. Ooh, there we go. Okay, so we're going to jump into this. Today, we're going to learn how to write a chemical reaction, okay? So there's two bits that I want to make sure that you have in our notes together. And it's small bits. So today we're going to be looking at chemical equations. We're going to understand the importance. That's what yesterday's was. Please make sure if you have not yet gotten on that assignment that you do that. That's a really easy 100, reading a short little article and answering 2 baby questions, like super easy 100 there for y'all. And then today we're going to start with talking about some symbology. Okay. And then we're going to talk about some basics with it and putting it all together. So here's what I would like you to write in your notes. Just down in the data table, that's why the star's right on the data table. We want to write that that arrow means produces or forms.
The whole symbol? The whole meanings?
Yep, we're going to write down the column of symbols and meanings. So that arrow means that produces or it forms or it makes or it creates, right? That's what that arrow is going to stand for. This one's not difficult. S means that it's a solid. An L is going to mean that it's liquid, and a G is going to mean that it's gas. Like those ones, like very, very basic, right? S solid, L liquid, G gas. AQ is the one that you probably haven't heard of before. And it's pronounced, you can say it two different ways. You can say aqueous or aqueous. Either way is fine. If it's an aqueous solution, it means that something's dissolved in. So it might be good to write that next to that aqueous part too. That it's dissolved in. So I told you we're going to be bringing back some nomenclature. So you might not be confused with the reaction part, but you might need some more practice with nomenclature. And if that's the case, you should definitely reach out for some help either Friday, tomorrow, right? You could simply go back and look at Unit 4 nomenclature, right? On your time, like your own time, like those are options for you to get help. This is also a great unit to reach out to the people at Upachieve. Remember, it's an app and you can get to it online. So upachieve.org, and that's a free 24-hour, 7-day-a-week tutor. And you don't got to see them. I know some of y'all worried about seeing a person you don't know. You don't turn on your camera. You don't even have to talk to them with your voice. You're just typing in a computer. Okay. But it's a real person that will help you and teach you, or even if you just want to check and be like, did I do this right? Like they will find someone very quickly to help with you with all that. The last symbol then is our plus sign, right? Which means in addition, with, plus, we're going to be talking about these things, okay? The top part up here, all reactants are on the left side of the arrow. So I would just write reactants equal left side.
Can you repeat that?
Yep, I'm putting it in the chat too.
We should write 2 bullet points of these, right?
Yep, reactants equal left side. And then products equal right side. And that sort of makes sense. Your reactants react to produce products, right? Like if you think about that, reactants are what we mix together to make something new. That's what we're going to be looking at today, is how we have this together. Now, by the end of this unit, you're going to be able to tell me what type of reaction it is. We're going to be able to balance the types of reactions. And so that's a big part of chemistry. The next part, before we start some practice here, you see in that red box there where it says H2, N2, O2, F2, write those down. Put diatomic molecules, and then please write down what's in that red box. So diatomic molecules. Diatomic molecules, and then write down what's in that red box. I'm going to tell you what they are in just 1 second. So diatomic molecules are simply atoms that can't be alone. Like they are so reactive that if they don't have a buddy to react with, they're going to find itself and react, right? So that's hydrogen and nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and acetine. We don't use acetine a whole lot, but he is a diatomic, right? It's sort of like the vowels, like when they say A, E, I, O, U, and sometimes like, what do they say? A, E, I, O, and sometimes U or something like that, right? We don't use acetine a whole lot. So here's what I want to show you in your reference tables with that. An easy way to remember these diatomic molecules is in your reference table. If you look at number 7, that is nitrogen. Right here. Okay. And so nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and acetine. So it's a 7 at 7. Notice how it makes that shape of a 7. And it starts at number 7. Those are my diatomic molecules. And then you just got little hydrogen hanging out here by himself. He's just sort of the weirdo over on that side. He's not with everyone else. He's trying to be a loner. So 7 at 7 here, right? Those are my diatomic molecules. And they're going to be important in a second when we start thinking about how are we going to create a chemical reaction, okay? All right, questions so far, because now we're going to get into some practice. Here's my biggest piece of advice. It's been a while since we did nomenclature. Some of you will self-evaluate and know that nomenclature was not your strongest unit. Don't get frustrated with this because you're getting stuck on the nomenclature. I promise we can work through the nomenclature. Okay, there are so many different tools that we can use to help you with nomenclature. So I promise you we can do that. So don't get frustrated and give up here on the reactions because you're stuck on nomenclature, okay?
Miss Milma,
Yeah.
is it supposed to be AT or AS? Because you got AS on the screen.
AT, I'll fix it real quick. Thank you, Amani.
You're welcome.
Let me fix it. Oh, go back, go back. Sorry, AS is arsenic. No, it's not letting me move over. No. All right, so now we're going to look at what this problem can look like for us. Okay. So this is the question we could get. Write the chemical equation for the following reaction below. And it gives us this all in words. So we have to take these words to symbols. Okay. That's what we're going to look at right now. This is the nomenclature part. Okay. If you get stuck here, please review your nomenclature. Specifically, I would look at ionic nomenclature. Okay. Ionic nomenclature is a big part of this. So we're going to do this problem together. And I'm going to put these notes up so that you'll have like the word problem and you can see how the equation came from that word problem so you don't have to write down all the words right now, okay? So we're going to look at this. I'll make this guy smaller. Oh, no, wrong button. There we go. Okay. So we are literally going to take this piece by piece by piece. Let me know if the screen's too small. I can try and make it bigger. But I think it'll be helpful to have like the screen and the problem at the same time. All right, so my first bit that I have to do is this barium nitrate. I'm going to take this piece by piece. I'm not going to get overwhelmed with all the words in there. I'm going to take it piece by piece. So barium nitrate is a chemical, like it's a ionic compound, right? Barium is Ba. I know that from my reference table. That's why I gave you that link today. So barium is right here. So that's a metal. That means barium has a +2 charge. So I'm going to write that there. Nitrate is a radical, and that's in the back of my periodic table. Remember your polyatomic ions? Nitrate is one of those guys there. So, and nitrate is NO3 -1. So that, remember, that is the first step in writing an equation, a chemical equation. Now, since it's ionic, we're going to cross our oxidation number. So the 1 would come down here, remember? But we don't write our 1. So the 1 comes down here. Then we're going to write NO3. It's a radical. So remember, we put parentheses. And the 2 is going to come down here. This is barium nitrate. That's the first part of the problem. And if you're like, dang, I sort of remember that, or if you're like, I don't remember that at all, look at ionic nomenclature. If something's not working, if there's a Nearpod that's not working, just let me know and I'll put the new code up. So now I'm done with this barium nitrate part. It's like crossed off. I don't need it anymore. Okay. I go now to this dissolved in water. That dissolved in water means aqueous. So I write a little AQ. That's it. I wrote the AQ because in the problem, right after barium nitrate, it says dissolved in water. If it said solid, I would have wrote an S. If it said liquid, I would have wrote an L. But because it says dissolved in water, I put AQ. Now here's the easiest one of the whole day. It says plus. Y'all see that it says dissolved in water plus. Plus. Right? The plus word means the plus sign. It could also say and. It could say reacts with, right? All of those things. The next part that I have here is potassium sulfate. So I need to make the chemical formula for potassium sulfate. I get my little handy dandy friend, my reference table. Potassium is number 19. It is a metal. So this is ionic. So I'm going to cross oxidation numbers. So I look up at the top, potassium's +1. It's going to be K +1. Sulfate is a radical. I look on my radical sheet, last page of my reference table. Sulfate is down here at the bottom. SO4 -2. This is ionic, so I'm going to cross my oxidation numbers. So K and the 2 from the sulfate is going to come down here. Sulfate's a radical, so I can go SO4 and I can put parentheses around it because it's a radical. And then there's a 1, but we don't write our 1s. It says dissolved in water. What would I write for dissolved in water? What symbol? S, L, G, or AQ? Good, Layla, exactly, AQ. So this 2 came down here. We're going to cross our oxidation numbers. And the 1 came down here, but we don't write 1s. There's implied. Now it says that this was reacts. Did I say the reactants? Because that's what this means. Like these two things are reacting. So it's a reactant. Is it going to be on the left side or the right side of the equation? Or the arrow, sorry. Would reactants be on left or right? Look at your notes. Good, Francis. The left. So I'm going to write that here. BaNO3, 2. I'm just copying this down sort of to make it a little neater. And it's on the left side of the arrow. Now, if this part is neat for you up here, go ahead and just put your arrow up there. You don't have to rewrite it. I was rewriting it because I made it look a little messy over here. So it might look complicated and it doesn't have to. So now I need to make my products. My first product, it says, is barium sulfate. So I'm just going to write down, here a little bit just so that you can see my process. And then I'll move my final one up here, okay? Because products are on the right side. So barium sulfate. Barium's on the reference table. It is a metal because it's on the left side of the stair step. And it has a +2 oxidation number. Since it's a metal, it's going to be ionic here. Sulfate is a radical. We just used it, right? So it was SO4 -2 for sulfate. It was a radical. I'm going to cross my oxidation numbers. So a 2 and a 2, right? We're crossing them. But those 2s are the same and one's positive and one negative. So it's like they cancel out. So we really have BaSO4, and you can definitely still put parentheses around it. That's my first product. But it says it's solid. It doesn't say it's dissolved in water this time. It says it's solid. So what do I write for solid? What symbol? S, L, G, or AQ? Perfect. Good, Brianna. Good, Francis. I'm going to put an S up here. And you want to make sure it looks like an S and not a 5. Some of y'all, when you're making your S's in your handwriting, it starts to look like a 5. So be careful with that. Plus, easy peasy lemon squeezy. So it's my plus sign. Now I need to make potassium nitrate. So again, potassium is on my reference table. So there's potassium. It's a metal because it's on the left side. And so it's going to be ionic. So I need to know its oxidation number +1. Just throw in my reference table. So, okay. We're going to make potassium nitrate. So K +1. Nitrate is a radical. We already used it up here. NO3 -1. It's ionic, so I'm going to cross oxidation numbers. So my 1 would go here and 1 would go here. We don't write 1s. So we would just have our parentheses. So KNO3. And is it going to be an S, an L, a G, or an AQ? What symbol am I going to put behind potassium nitrate? S, L, G, or AQ? Good, AQ. So this guy here, this is my chemical equation or my reaction. By the end of this unit, you're going to be able to tell me that this is double displacement. You're going to be able to balance it. Okay. We're going to take it slow, so don't stress out about it. But those are that's sort of like where we're looking ahead to. Again, you might not be so confused on the reaction part. Like you're good. You know, products are on the right and reactants are on the left. You know that A, Q, and S and L and G part, but you might need some nomenclature practice. That doesn't mean you don't know chemical reactions. It means you're struggling with nomenclature. Okay, so make sure you flip that in your brain. It's not that this is so impossible. It's that you've been struggling a little bit with nomenclature. We need to get some help. Questions, comments, concerns? Not all of them are this long. So we're about to look at one that is significantly shorter. This guy right here. Right? So it says magnesium metal burns in oxygen gas with a bright white light to make a white powder called magnesium oxide. If we were in school right now, we would do this. We would have done this lab already. We would have burnt some magnesium ribbon, which is a very, very bright white light. But I can't send it home for you guys to do it because the gas is toxic. And so we have to do it underneath the hood, which we have at school, which you guys don't have in your house. You would just fill up your room with toxic gas. Okay, so we're gonna look at this magnesium metal here. Magnesium metal, so it's pretty simple here. It is just Mg. And if you noticed in this problem, it says the magnesium metal burns an oxygen gas with a bright white light to make. That means the magnesium and oxygen are your reactants, right? What's coming first there is your reactants. Those two things are being mixed together to make something else. So this is not a compound. This is just solid magnesium. And I know it's solid because it says a metal. When you think of a metal, I hope that the first phase of matter that pops into your head is a solid, right? It's very unlikely for you to have a liquid metal. Mercury is the only one. The other ones are way too hot for you, right? You're not going to have a mercury, or you're not going to have a gas metal. That would be way too hot of a temperature. So I'm going to put a little S down here because it's a metal, and that means solid. My other reactant is my oxygen gas. What's my symbol for oxygen? Good, it's O. Now, here's the tricky part with this one. Oxygen is one of those diatomic molecules. Right? Oxygen. So we can't just have oxygen sitting alone, right? It's not just ever going to be O. If anything, it's got to be O2. So I add that 2 here because oxygen's diatomic. I do not add it for magnesium because magnesium is not diatomic. And remember, we listed those in our notes, our diatomics, right here. And then hydrogen. It's oxygen gas. So am I going to put an S, an L, a G, or an AQ? Exactly. Those two things, it says make, it says with a bright white light to make white powder. Okay, so these two things are mixing together to make. So there comes my arrow now. Because now I'm going to talk about what I'm making. And it says that I'm making a white powder called magnesium oxide. So I need to use my reference table because now I'm making a compound. These two things were separate. It was just magnesium. It was just oxygen. but now they're coming together to make magnesium oxide. So I find magnesium, he's right here. He's a metal. So that means we're going to have an ionic formula because I have a metal. So I go up to the top and its charge is +2. So I'm going to have Mg. Sorry, I'm going to write that up here first. Mg +2. Oxide is oxygen. Remember, that's part of the rules with ionic is you change the ending to IDE, oxygen, oxide, nitrogen, nitride. So oxygen's right here. It's O, and its charge is -2. So O, -2. So I would cross my oxidation numbers here. So Mg2, O2, they're the same. So they cancel. So I would just have MgO. It says it's a white powder. What phase of matter would you think a powder is in? Is it going to be a solid, a liquid, a gas, or aqueous? So it's solid, right? Think about any powder that you've seen, like if you have a pressed powder that you use for makeup or anything, flour is a powder, sugar is a powder, right? Those are all solids, okay? So this, when it says that it's a white powder, it's a solid substance then here. Questions about this at all? Okay. So if your homework tonight is really nothing other than to sort of let this like mellow in your brain, maybe you need to go back and look at nomenclature tonight, and that could be something. Your async work tomorrow is practicing writing equations. If you get stuck tomorrow, right, you should be ready on Thursday to ask me some questions so that we can go through that, okay? You're going to notice that Wednesday's async work is not going to be due until Friday so that you can ask questions in class on Thursday if you get stuck, okay? Because I don't know how available I'll be all day Wednesday because, you know, I'm in school on Wednesday with students who have chosen to come back, okay? So if you get stuck, you can text me, of course. You can reach out to Upchieve. Please know if you're texting me, be patient a little bit because I am at school, okay? And if you still don't hear back from me, be ready to ask me the questions Thursday in class. We also tomorrow night have our ACT info session. If you have not yet taken the ACT, it is very imperative that you are there because we are going to offer another testing at school. That one will be free if you haven't yet taken the ACT on May 5th. I highly recommend that you take that one. Okay. If you want to retake your ACT, you should also come so that you can find out some information about how you go about and when we're going to register for that too. Okay. So ACT review session tomorrow at 6:30 via Zoom. It should already be on your calendar. Otherwise, I will see you guys later. I'll hang back for a few, but if you have any questions, let me know. Bye, guys.
Ms. Newman.